Right, we'll try that again. Hey, and welcome to John Park's workshop. It's me, John Park, and now my microphone is on, so that's really so much better. And thank you you can hear my alert beeps back there. We should catch up in a second here. And who told me bloops and bleeps are a go? Oh, I know why. Thanks, Andy Calloway. Yeah, my music was working, just not my mic, because I was being silly. So here we are, off to a spectacular start. And let me know if you can hear me now, because I think we're all set. Right, Matambale? Right, Mr. Certainly? Right, C. Grover? I'm counting on you guys. Seems like it's working now. I see actual VU meter action in my software this time. So I will await confirmation and have a sip of iced tea. Excellent. All right. Thanks, Mr. Certainly. Now we're ready to go. So here we are. This is John Park's workshop, where we futz around with microphones and try to make them work, as well as talk about some cool gadgets and gizmos and tech stuff, and tips for building things and coding stuff. You know, we're on a video game jag right now, so we're going to be doing some cool video game stuff. But first, let's mention our jobs board. So you can head over to jobs.adafruit.com and check out the highly excellent posts that are out there for positions people are looking to hire. Here's the jobs board, and I noticed this one, a new one up at the top here. Web developer / designer who's familiar with Arduino and ESP32 development. It's a remote position. And this is for something I hadn't heard of. It's called Spool. Spool. They've got an umlaut. You've got to really lean into that umlaut if you've got an umlaut. Don't just make it look cool. Please say it cool. Please call that Spool. So Spool Tracker is a 3D filament tracker, I believe, that's going to be web enabled to keep you from running out, a runout detector, filament manager and tracker. Pretty cool. So go check that out. That's a job posting over on jobs.adafruit.com. And you can also post your resume if you're looking for work. And the cool thing is it's free. It's free if you're posting. It's free if you are trying to get work or trying to hire someone. So please go check out jobs.adafruit.com. That's a real thing that exists and is cool. All right. What else? Hey, I've got a coupon code for you. And the coupon code today is XY Pizza. So if you use this coupon code right here, XY Pizza, just go to Adafruit and throw some things in your cart that you want to buy, and on checkout, type in XY Pizza, and you're going to get 10% off. And speaking of things that you might want to get at the Adafruit store, how about a product of the week? That's right, I have selected something that I want to remind you about that I think is pretty great in the store, and that is this. It is the Prop Maker Featherwing. I have one right here. In fact, I've got it hooked up to a super crazy bright 3-watt LED. So it's pretty cool. You plug it into a feather, and then it makes life a lot easier if you're building props. Particularly, I gotta say it, lightsabers, but also great for anything you can imagine. Shields, cosplay things, could be peaceful, happy stuff, could be warlike stuff, ray guns perhaps. So I have it here on, I think, one of the M0 Bluetooth Bluefruit feathers, but really works great with M0 Express and M4 Express, particularly if you're going to do audio stuff or lots of PWM. But it has built onto it a driver for this crazy bright LED in here that I've got this 3-watt LED. I put it in a Game Boy case for a diffuser. And I'm using the accelerometer that's built onto the Prop Maker Featherwing to change colors. So you'll see the reflection on my hand better because so I've got it changing right now just because I've got that tilted up. You can set it back and leave it alone. So you can imagine that's really great for doing color changing effects. It's also got audio out built onto it and a NeoPixel out built onto it. And then you can use buttons and things with it. But particularly if you want to build stuff that's reactive to motion and tap detection, the accelerometer built right onto there, as well as the drivers for driving your lights and sound, make it super cool. So go check out the Prop Maker Featherwing. The thing is cool. It's also super bright. Let's turn that over so it doesn't blind me. Actually, let me show you. Here's the without the diffuser, just so you can see what I'm using here. This is one of these really bright. I'm going to point it at me so you can see the back. It's got a heat sink on it. I think it's a 3-watt that we have there. It's warm. So that's the product of the week, is the Prop Maker Featherwing. And I believe we now have a version that comes pre-soldered with the headers, or the one that we've had previously, which you have to solder the headers in yourself or choose not to, depending on what connections you're making and how. So that's my product of the week. And that brings us to this. It is the MakeCode Minute. And what I want to talk about today in the MakeCode Minute is using the screen width and screen height parameters to sort of procedurally set things in different positions on the screen. So what you'll see right here is I have a simple scene here. I'm going to zoom into the code because I don't have much of it. And I'm going to run my simulator. And you can see I've got a new sprite. It's a slice of pizza. And it's going to be on these XY coordinates. Now, what if I want to put it, let's say, at the 1/3 of the width and 1/4 of the height down? Rather than doing the math, I know this is a 160 by 120 pixel screen, but it's kind of nice to do these sorts of things procedurally. And so inside of scene, we have these parameters, screen width and screen height. So if I grab one of those and just set it in here, it's going to go all the way to the right, because that value is 160. So the center of this sprite just landed there. But if I get a little fancy and use some math blocks, I can say, how about set the width to whatever the screen width is, or sorry, the X position to whatever the screen width is divided by 3. And now we'll be 1/3 across the screen. We can do the same with height. So there's a screen height block. Let me zoom out of here. I know that's getting a little big. Can you see that? Yes. So now I can say, let's go to 1/4 of the way down. Okay, so this is a kind of simple case, but now check it out where I've fleshed this out a bit more. And now I have a scene where you'll see again, if I zoom in, I've got a variable called width segment, and I'm setting that to that screen width parameter, and I'm dividing by a number of columns, which is another variable I've put in here. So right now I've got it to 5 columns and 4 rows. So look what happens. Now, when I use my arrow keys, I'm just changing the variable of which of those sort of column segments or row segments I'm on. I even made it a little fancy. If I press a button, press the A key, I can see a little background that's related to the current width and height segments. Or if I chop it up more, I did not have to go in there and figure out the math, or rather the exact coordinates kind of laboriously. Instead, I'm using a nice little procedural formula to decide where I am on the screen. And so that is how you can use the screen width and screen height parameters to place objects inside of MakeCode Arcade. All right, there we are. Hey, look, there's me. There's another me. Let me get rid of that one. That was freaking me out. So I am really excited about figuring out some of those methods. And actually, Lady Ada and I were talking about a game demo she's working on, and using things like the columns and rows and this procedural screen width or tile maps makes it really nice to build puzzle games. So there may be a puzzle game or two in our future here working on MakeCode Arcade stuff, and I hope you take some of that info from that MakeCode Minute and go build your own MakeCode Arcade games, trying to use some of these methods that you'll see once you start using variables and little function loops that you can call and procedural things like the width and height. life becomes a lot neater inside of MakeCode Arcade and any programming environment really, and it allows you to be a little bit of setup at the beginning makes it quicker and easier to then change things later on and adjust. For example, if you wanted to build a new level, you could change things in a simple way rather than kind of rebuilding everything from scratch for the next level. So I think those will be some helpful tips for people who are making their games. So let's see. I want to do a quick jump over to the workbench because I meant to show you this. So I mentioned I might start to do a sort of a mailbag segment, or here's a cool new thing I found, or in this case was given. So this is an incredibly cool clock that C. Grover from our chat, our own C. Grover, thank you so much, built. And I forget the name of the original designer. And so someone, maybe someone can, oh, let me pick a different camera for that. Ooh, aha, my camera, that camera went out. Hang on. Whoa, whoa, whoa. Sorry about that, I'm gonna fix the camera. Meanwhile, if someone in the chat wants to pull that up, yeah, I think my camera overheated. Yay, it's getting to that time of year again where I need to actively cool this camera. Yeah, someone can find the designer of this clock. So the idea behind it is that it has this very clever arrangement of letters that allow it to give you sort of plain English language descriptions of the time. It's not going to be accurate down to the minute, or it doesn't tell you down to the minute what the time is, but it's pretty cool. So right now it says 1:15. So you can see I had to pick a 1 from here and the NE from there, but it's pretty readable. So this uses, oh, Russ Hughes adapted the design. Okay, so that's the adapter of the design. And it uses a real-time clock chip in there to keep the time. I can't remember. Okay, I've got it screwed together, so I'm not gonna try to guess what's in there because I haven't gone very far into taking it apart. But it is very cool, and we'll post a link up in the Discord chat if someone finds that. I think it exists probably on Thingiverse, and as a model you can find, or perhaps it's been published somewhere else. But very cool little project. I've seen these sorts of things before, and I'm really impressed. Also, C. Grover was saying he's really impressed with the clever diffusion. I think it's a 3D printed layer to diffuse the pixels through a white layer. Yeah, so there's a Thingiverse link, and that has been found by Mr. Certainly. Thank you so much. And so if you're interested in finding out more, go check that out in the Discord chat. And if anyone wants to paste that over into other chats, that would be awesome. Thank you. In fact, let me just jump to my browser real quick, and I'll open up that link so that people can see it. Oops. All right, so there's a few of them, huh? And 3D printable Neomatrix 8x8 world clock. Word clock, sorry, word clock. Oh, there's lots of them. Yeah, okay, so I don't know the history of it. Someone made this first, I'm guessing. It probably didn't occur to everyone on the planet simultaneously, but there are a lot of them there, so go check those out. Very cool. And I kind of like thinking of time that way, as sort of half past this, quarter past that, roughly this and that, instead of getting caught up in minutes. What are these minutes of yours? All right, so let's now take a journey over into our project of the week. So I'm gonna actually jump over here, and let's see if you can hear this. It's got, I think I've got the sound. Oops. Sound set up for this as well. All right, that's all of the song that I got done. So that is Spy Hunter, if you're not familiar with it. And I've got a MakeCode session over here where I'm going to show you how I've started going about this. So this is a work in progress, but it's going to get some additions and refinements, and we might even work on a little bit of it live here, do a little live coding. to see what my process is of going and adding features to the game. So I'm going to turn off the audio. So you can turn off audio inside of the simulator here. And so you can see I've currently got it to where I'm using the D-pad. If you look, you can see the D-pad simulator graphic showing which way I'm pointed. So even if I'm holding the right key down, I'm actually stopping on that yellow line, excuse me, as a wall in game terms. And I've got up for accelerate and down for hitting the brakes. And then I've got these two sort of enemy cars, excuse me, or they could be innocent bystander cars coming into the screen. And the cool thing is, at this point, what I'm showing you here is almost entirely stock graphics and simple blocks. So I'd like to go over how some of that is. There's a couple custom things in here, and then as we get more gameplay into it, we'll be adding more complexity and more blocks and maybe some more custom graphics. So let me stop the simulator there. And now let's dive in. Make sure you can see. Yeah, okay, so you can see up to about there. Let's dive into how we're going about this. So we'll start at the start. So the first thing I'm doing, I'm setting a background color to black, and that's what you're seeing through on the road there. And then I've created a tile map. And so my tile map, I'm using it, in the case of these green sections, I'm actually using it as the graphic. So I've set down tile maps with the index block of green, and I'm not using them for game function right now. Very often you'll use them both for a game function and to place an instance of a tile. But right now the green is just being my grass. If we decide to create a little grass map, texture map or tile, then that's where it'll show up. And then I'm using a white stripe for this left road paint stripe and a beige one for the right. And I'm also setting those to be walls. So you'll see here, this next block is set tile to, and then I have a graphic followed by with wall on. Oh, actually, you know what? Yeah, do I want to do it this way? Yeah, we can do it this way. Okay, so I had changed my mind. So I'm actually using most of the tile map for the green and then a little edge of it for this yellow, just so that I get a thin yellow stripe and a thin black stripe for the edge of the asphalt. And so then I have one on the right side that switches where that is. So if we continue on, and we'll come back to looking at adjusting those once we get the sort of basic setup. So then I've got a sprite that I'm creating that's called the car, and I'm just grabbing a car sprite out of the gallery. I might have edited this one slightly. I don't think there's a pink roofed one. Oh, there is. Yeah, so there's this pink and purple car right here. So that, by selecting it in the gallery, we can now edit it. So let's say we want a yellow roof on our car for whatever reason. There, a little bit of yellow paint. So you'll now see when I start the simulator again, I can make it full screen, now our car has yellow. Another thing to note is, I think it was in a beta a couple versions ago in MakeCode Arcade, and I'm always using the beta at this point because I'm working with Pygamer, and to get the thumbstick to work I need to work in the beta. A couple versions ago, they stopped automatically running the simulator all the time, so it was getting too slow and annoying. I think every time you changed a block out for it to take a moment to compile and run. So now while you're working, it's not running until you hit play. So now I'm creating that car. This is something new I want to talk about. I don't know if we've mentioned this before. I'm setting the car to have a certain Z-depth. So if you think of the game in terms of a two-dimensional game, it has X and Y. Horizontal is X and vertical is Y. What Z-depth is the drawing order of sprites. So if I have this yellow Post-it note and this red 3D printed Pi badge, if I want the orange thing to appear on top of the red thing, and they're occupying or overlapping in 2D space, then we use this Z-depth setting to say the lowest stuff, the tiles, I think are at -1. I think your average thing comes in at 0, and then you can place something at 1 so that we determine who's where. So I'm placing this car pretty high up. It's a layer 4. So you can think of it as layers, like layers of transparency sheets or layers in Photoshop, if that's how you think. So that's what this car Z-depth is. Right now, if I set it, let's say to 0, you're going to notice that my car will be going underneath the paint stripes. So you see those white paint stripes are now on top of me. And that is not the effect I'm looking for. So in order to combat that, when you're making MakeCode arcade games, keep in mind that you can go to this sprites and then set my sprite parameter dropdown. It starts life as x2 and then a number. So if we pull that in, and that's what I've already got in here, you can see originally it was set, where's the x? Now I'm saying let's set the z, and it helpfully reminds you there in parentheses that that's the depth. So I'm going to set this, pop this up a higher level, back up to 4. And lastly, I'm moving the car with the controller move my sprite with buttons block. And when you bring that into your scene and then hit the plus sign, like this, it allows you to determine the velocity on x and the velocity on y. So I'm setting the velocity on x to 100, so it moves pretty fast left and right. That's the steering. And then on y is the acceleration and the brakes. So it's fairly simple. I don't have a big difference between accelerating and braking. I have no difference. They happen at the same speed. But it seems to be good so far with the game the way we're doing it. So now I mentioned we would look at these tile maps on the side. So ignoring for a moment that I have trees and bushes going by, should we? Yeah, you know what? No, let's not ignore that. Let's look at exactly that, because that's important. That's how this illusion is presented. So what I don't have is a really long game level. If you think of the level design that we did for the platformer game using our Blinka LED, we built a tile map that was narrow, or it was short and wide, really wide. And so those represented the different, more than the width of the screen, areas that we could travel. So you can make, particularly for like a role-playing game for an RPG, you might make a big tile map so you can visit a bunch of different areas. Think of a Zelda type of game. But in this case, it does not make sense to try to make a 4,000 pixel high tile map. Maybe it would let you, I'm not sure, I haven't tried. Instead, what I'm doing is a bunch of cheats. So I am essentially spawning the stripes of paint in the middle of the road as particles moving at a certain speed. And then I am, and those are very regularly arranged. So let's look at those. So I've got the black background, and then I've got, I'm going to use my zoom to find it. There it is. I've got this on-game update and then I've decided at every 200 milliseconds, if I update at that speed, that's a nice rate of relative speed that we perceive as those stripes go by. And you'll notice I specifically chose these dots because we see motion in them, versus if it were a straight white line or double yellow, you wouldn't perceive any motion. So these are projectiles, and each projectile is, if you can see it here, let me paint it red so you can see a little better. That's what my road stripes look like, and I'm sending them, when you create a projectile, this is under sprites, you can set projectile to projectile from the side with, and then you give a velocity. So, can I close that? There we go. So I'm projecting them with a velocity on y of 100. So every 200 milliseconds ones appear, and then it zips down at 100, the velocity of 100 units. Then I'm setting the position of the projectile. So this relates to that MakeCode minute. Where is it going to be? I just wanted it in the dead middle of the screen, and rather than do the math, I just said, okay, set the x to whatever the screen width is, divided by 2. Right? So the nice thing is, if this were going to play on different devices with different sizes of screen, we don't have to sort of recompile that for different versions or recode that for different versions. As it's compiled for a different device, it's going to take into account what is that device reporting its screen width to be. So we get right in the middle screen with that screen width divided by 2 right there. And then you can see I'm setting the projectile's Z-depth to 1. I could probably set that to 0. I don't think anything is going under it other than tiles, and those are set to -1. So then what I'm doing, a similar thing there, is to send these bushes and trees down the side. Again, I'm sending a projectile at that same rate. So it's important that the paint stripes and the bushes travel at the same rate, otherwise it's going to look like this is an escalator in the middle or something. So that rate is going to be the same. However, I don't need the regular spacing that I get of those paint stripes, which is this 200 milliseconds. So instead, I'm picking a random value. So on every roughly second, half a second to a second, so I'm saying 600 to 900 milliseconds, send one of these bushes. And then its x location I'm picking is a random value as well from 0 to 30, so the left side of the screen. And then you can see I have another one that travels same rate but spawns at a different range, and those are off to the right, so that's 130 to 150 pixels. Now I should be good on my word and use the screen width divided by thing and make a little range. I didn't, but so these are going to be constrained to 30 and 150. So if we got on a really wide screen, we would have a problem. So once you start using something like this, you probably want to be consistent with it, but I didn't yet. I was being bad. And so then same with, I have these trees. I think they only appear on the left side. So if we wanted to create trees on the other side, we could duplicate this. Let's make them happen a lot. How about 200 to 400 milliseconds, and that right side, is that where I want it? Yeah, what did I say, 130 to 150? And we'll put those above the bushes. So this is a way I could make sure that they appear above the bushes. So now we should start to see lots of trees over here on the right. And when they do appear in the same space as a bush, they're going to be on top of the bush. So that's a nice way to do what is essentially a procedural, in some ways a procedural level design. We did not have to create a gigantic graphic. We did not have to deal with a very large tile map and sprites stuck to it. Instead, we are telling it to pop these things up for us, and the randomness is good because it means we have a never repeating design. If, by the way, you were to have a different velocity for one of these objects, it's going to throw the whole thing off. It's going to look like there's actually a bush driving because it's got to be locked down to the world there. Okay, so now the interesting thing is that the cars, these enemies and bystanders, they're following the same exact mechanism. So let me see, can you see all of that screen? Whoa, that is very large. Let me zoom that out just a little bit. Come back here. You see that? Good. So on every 5 to 10 seconds, I get a random value being selected. I'm sending a projectile that is the car with the purple roof, so it's coming up from the bottom. Negative 50 is the speed that it's traveling upward on Y, 0 on X. And what I wanted for these ones is a little bit dastardly. I want them to, when they start, they're right behind me. So you'll notice that no matter where I put my car with the yellow roof there, when one of those purple roof bad guys comes along, he is right on my tail. So let me go to the top of the screen here so it's not as dire. Okay, so I got to get out of his way. These other guys are coming randomly, but I made those guys be a little trickier. Okay, so now let's get to adding something. In fact, I'm gonna drag in a newer version of this that I was working on. And some of this I had to clean up variable names. I had given a whole bunch of things the same default variable name, which works up to a point until it stops working. So now this is how we're going to set up what happens when we get hit, when we occupy the same spot. So you can see it's a little simplistic right now, but it's going to happen every time because those bad guy cars are coming. Whoop, he's going to hit me off to the side. Bad guy car is coming up from underneath, and bam, I get popped over. So how I'm doing that is with, let's zoom back out, a overlap block. And so this is under sprites. Just look for the big one here, one of the big ones here. On sprite of kind player overlaps other sprite of kind player. So then we go in and adjust those things. So now I'm saying there's going to be two sprites. Think of them as A and B, or sprite and other sprite. So there's two sprites involved. I'm going to say if the first one is a player and the other one is a projectile, and you'll notice that doesn't narrow it down that much. So then I'm going to go in and actually pick it by name. So in that case, when those things overlap each other, then I grabbed this if-then statement from the logic area. So if true, then. And I got a comparator. So one of these comparisons, if 0 equals 0, grab that in there. And then I'm saying if the other sprite, so remember, we've already got something happening where in memory it's thinking, okay, sprite, player, and other sprite, some kind of projectile. Then we say, okay, this guy who's being called other sprite at the moment, does he happen to have the name enemy A or enemy B? And that's why I have these if and else if. Then I say do something. And what I'm doing right now is a real simple one from sprites, which is this set my x, or rather change my x position by some value. So I'm saying if that happens, change the car and bump it off -16 to the left. Let's make this a little more interesting. I'm going to duplicate that in both cases. And I'm going to say, let's move my car -8. And I'll move the other car 8. So I'm going to change enemy A. So that means rather than he wins and I get bumped out of the way, we're both going to go halfway to the sides. And you can imagine you would then set up things like damage. How about these guys cause us to bump to the right, and they go to the left. So change enemy B, and now let's take a look at how that works. Boom. You see, I got bumped and so did he. So we get a little collision there. And now we're out of each other's way. Now, you would probably then want to go ahead and create some damage conditions and things like that. I'm not going to add that right now, but that can be as simple as when this occurs, we're going to lose a life. So if you remember some of our previous MakeCode Arcade, we have the set lives. So we can say there's 3 lives to begin with, and then when some event occurs, we change a life. Or we get a little more sophisticated with it and play an animation and an effect, and maybe rather than losing a life right away, we reduce some health counter until it gets to a certain point, and then we lose a life. So you can see that a lot of these concepts can be woven together from the different games that we've been making. And let's see. So I'm curious if there's any questions in the chat at this point about how the game is made. The music is similar to the things we've done before. I've actually got some polyphony. Let's see if I can. No, will you hear that? Yeah, let's try this here. I'm going to turn my volume down. You'll listen to this for a second. No, I'll leave my volume up. Here we go. No, it doesn't want. Whoa, just wants to hear me. All right. Sorry about that. That's not going to play. Only going to hear the sound off of the handheld. But what I'm referring to is I actually have 2 of these forever loops. Oh, that's why it didn't play. Let's see if we can get it to. I gave myself sort of a mute switch there. So there are 2 different. There's a bass line and a lead line, and those are actually both going to play together. Okay, so let me stop that and take my echo off. So that is the same sort of music stuff we've done before. I'm creating a pair of functions that are the bass line here and the lead line here. And then I just loop through the bass line constantly. And then I give myself a couple bars of rest at the top of the lead line so that it lets the bass line play. And then it just plays it again. I haven't done much with polyphony inside of MakeCode Arcade, but it seems to be working really well and working well on the handheld as well, which is pretty darn cool. FX Music said, hey, that's cool music. That is, if you're not familiar with the game, that's actually a song by Henry Mancini called the Peter Gunn theme, and it is awesome, and I don't know how they ever got rights to put that in the game, but they did. Also, interesting fact, I read that Spy Hunter was originally going to be a James Bond-themed game, but it didn't work out for them. So now let's see. We are out of time, so I'm going to stop there. But you can imagine I've got some plans to add in a little bit of, let's turn this back on for you, a little bit of smoke screens and oil slicks and that kind of stuff. I'm going to set the volume to 0 there, let that play. And if we're able to, if I have time and the capability to figure it out, or if Lady Ada also has time and can help me figure it out, I'm going to try to do some shifting roads, because this type of top-down racing game, again, I'm building it procedurally. If we can figure out how to make everything from sprites or tiles so that we can shift where that line is, and maybe even shift obstacles so that you have to avoid the edges, then we can make this sort of endless. And again, it can be procedural with some randomness in it, or not sure exactly how we're going to do it, but that's my goal, is to create some shifting roads in here. So again, my mind continuing to be blown by the things that we can do inside of MakeCode Arcade. So go check it out. And I'd say, if you're interested, go sign up for the Pi Badge or the Pi Badge LC or the Pi Gamer to be alerted when those are in stock. And in the meantime, if you're looking to get any other great Adafruit stuff, such as our prop maker Featherwing that we showed today, then get yourself 10% off with XY Pizza as your coupon code of the day. And with that, I'm going to say goodbye. This has been John Park for Adafruit Industries on John Park's Workshop, and I'll see you next time.